Higgs boson,
चंद्रशेखर लिमिट,
string theory,
न्यूट्रिनोस,
quantum entanglement.
कुछ समझा क्या?
Ever felt bored and confused while reading lengthy physics textbooks or articles?
Yeah, on God, bro.
I'm Arnav,
And I'm Pratham.
and welcome to Quark Talk, where we decode all the complexities and simplify these intricate concepts in physics.
They may have seemed too complex to understand until now.
Getting to space right now is like trying to push a refrigerator up a water slide.
Wait, what?
Yeah, it's slippery and there's a good chance you'll get crushed in the process.
I mean, sounds about right. And let me guess, the refrigerator's full of explosives?
Yeah, it's not just dangerous, it's slow, expensive, and frankly inefficient. Right now, rockets are just basically fuel tanks with a tiny payload on top. It's not the most elegant solution, especially when you need to haul a ton of stuff to places like Mars. It's like trying to move into a new apartment with just a scooter instead of a moving truck.
And that scooter might just blow up.
Exactly. So rockets need to hit speeds of like 40,000 kilometers an hour just to escape Earth. So most of their mass is necessarily fuel. That's fine if you're just putting up satellites, but if you're talking about interplanetary civilizations and heading to Mars like Elon Musk wants to, you might want to bring, I don't know, food and water and air for the occasional human, right? Yeah. So we're going to need a better plan.
So you're telling me that the interplanetary road trip of the future isn't bring your own everything?
Not unless you want to strap on extra rocket boosters to your ice cream machine. But here's the thing. What makes travel on Earth so convenient is infrastructure, right? Roads, rails, ports. They make it easy to move stuff around, including humans, right?
So we're talking about upgrading from refrigerator on a water slide levels of effort to something smarter, like highways in space.
Bingo. And while we don't have highways or space toll booths yet, thankfully, there's already a promising idea. The Skyhook.
The Skyhook? That sounds like something from a James Bond movie.
It does, doesn't it? But it's a real concept. Imagine a massive tether, a cable, and a counterweight all hanging out in space.
That's just a really dramatic way of saying big rope, isn't it?
I mean, it's a big strong rope, yes, but hear me out. This tether could act like a ladder for spacecraft to climb, saving tons of fuel. Now, if we make it spin, it gets even cooler.
The spinning motion allows the tether to fling spacecraft into orbit or even higher speeds, like a giant catapult.
Right, so instead of rockets thrusting off the ground, we'd yeet them into space?
Yeah.
The tether slows down at the bottom of its spin and speeds up at the top, giving the spacecraft a massive energy boost because of the conservation of angular momentum, right?
Okay, but what stops this giant rope from getting snapped or sliced by like a random space rock?
Good question. We'd have to use specialized fibers, materials we already have that can handle the stress. And to deal with space debris, we designed the tether as a web of redundant fibers. Even if one part is damaged, the system should stay intact.
So it's like giving the tether a bulletproof vest. Space-proof vest?
Pretty much. But here's the tricky part. At its lowest point, the Skyhook's tip would be zooming through the atmosphere at 12,000 kilometers an hour. It can't dip too low, otherwise it'll overheat from air friction because of our atmosphere. So it'll hover around like 80 to 150 kilometers above the Earth.
And let me guess, that's not exactly the neighborhood your average rocket can just pop by.
Nope, we need small reusable spacecraft to meet the Skyhook at those altitudes. It's still much cheaper than getting a full-size rocket to 40,000 kilometers an hour though, kind of like Elon Musk's vision, right? Getting small reusable spacecrafts.
So instead of hauling everything to space on one big trip, we're breaking it up into stages like an interstellar relay race.
Exactly. If we get this right, it could make space travel cheaper, safer, and way more practical. Imagine reusable space taxis instead of rockets just zipping up to a Skyhook and flinging cargo to Mars.
Space taxis, so what? Uber Galactic?
More like space lift or star Teslas. Sleek, self-piloting ships with zero-gravity seats and solar charging stations orbiting every planet. Forget road trips. We're taking galaxy tours.
I don't care what it's called as long as they don't charge extra for my carry-on.
Fair enough. So let's get real. We've got the Skyhook concept. It's essentially a tether swing around in orbit, making space travel efficient and affordable. But man, catching the tip of it, yeah, it's 12,000 kilometers. Like its speed is 12,000 kilometers an hour. That's no walk in the park.
Oh, absolutely. You've got a tiny target moving at Mach 12 and a window of just 60 to 90 seconds to grab it. It's like trying to catch a fly with chopsticks while standing on a roller coaster.
Spot on. And the solution? Think of a high-tech fishing line. A kilometer long with a navigation drone at the end to guide spacecraft in. It's not elegant, but it gets the job done.
I like it. A little Here spaceship beacon to make the connection smoother. But okay, you say catch the tether. What next?
So that's where the Skyhook's real genius kicks in. The thing acts as a giant orbital battery. Like incoming ships, they bring in people and cargo back to Earth, right?
Yeah.
And they add energy to it as they slow down.
Correct.
But outgoing ships can use that stored energy for a boost into space.
So it's not just flinging stuff, it's also conserving momentum. But what if there's an imbalance? What if we have more outgoing payloads than incoming?
Good question. If we start losing like energy overall, we'd have to recharge the tether. It's like small electronic or chemical thrusters could nudge it back into position, keeping it in orbit.
A little maintenance for a lot of benefit. And this isn't just for Earth, right? You could set up a tether on Mars too.
Exactly. The Earth tether could launch ships to Mars, and the Mars tether would catch them, slow them down, and then guide them to the surface.
And in the opposite direction?
Even better, Mars's thin atmosphere makes it easier to pick up ships that traveling around like 1,000 kilometers per hour, which is not much faster than a jetliner here on Earth. So the tether flings them back to Earth to be caught and lowered safely.
That's brilliant. So we're cutting down travel time between Earth and Mars from 9 months to as little as 3 and slashing rocket size by what, like 84 to 96%?
Exactly, that's like a huge difference, right? That means smaller rockets, lower costs, and even maybe a touch of luxury. If the savings are significant, we could invest in passenger comfort. Imagine first class seats to Mars instead of cramped capsules.
Now that's something I'd sign up for. Space travel without the misery of airline peanuts. But why stop at Earth and Mars?
Glad you asked. With a tether in low mass orbit, you can start reaching further. The asteroid belt is just a swing away.
Mining asteroids, huh? That's the ultimate treasure hunt in space.
Exactly. The first ships would still need rockets to slow down at their destination, but that's like they're going so fast they would need to slow down. But once you set up a tether at the asteroids, also everything changes. Ships can dock, load up on precious materials, and get flung back to Mars, and then again back to Earth. Right? No extra fuel required.
And imagine the speed. Weeks instead of months to deliver materials that could fuel an entire Martian economy.
And it's not just about Mars. With enough tethers, you could connect the entire inner solar system. Ships to Venus, Mercury, or even Jupiter and Saturn. It's all within reach.
And the possibilities are endless. And what is the best part? The more we use the system, the cheaper it gets.
Right. Space travel that gets more efficient with every trip. Kind of like how Elon Musk is like pushing with electric cars, right?
Yeah.
Robo taxis and cyber cabs. I mean, it's a far cry from the one-off rocket launches that we are used to now, but Skyhooks might be a thing.
So this is the roadmap for a true interplanetary civilization. Tethers around Earth and Mars, expanding to asteroids and beyond wherever it is.
And technically, we can start today. The technology exists. It's just a matter of vision and will.
That's what blows my mind. The universe feels so vast, but with these tethers, it could be within an arm's reach.
One connection at a time, Pratham. That's how we shrink the solar system.
And redefine humanity's future. Let's get to work.
So, we were talking about how Earth and Mars tethers could kickstart an interplanetary highway, right? But here's the thing. Mars itself has an ace up its sleeve that makes it even better.
Oh, what are we talking about now?
Mars's moons, Phobos and Deimos, whatever.
Yeah, you just
Butchered
butchered
it,
it.
yeah. Especially Phobos, but forget about Deimos or whatever. Phobos is the main guy. It's like the unsung hero of the solar system.
The tiny potato-shaped rock orbiting Mars. What's so special about that?
Well, that tiny potato-shaped rock orbits closer to its planet than any other moon in the solar system, just 6,000 kilometers above Mars. And that makes it perfect for something big, a super tether.
A super tether. You're telling me we could attach a massive tether to Phobos?
That's exactly what I'm saying. Phobos is conveniently heavy enough that we wouldn't have to worry about it drifting out of orbit, and a 6,000 kilometer tether could extend almost to the Martian surface on one end.
So the lower tip just skims above the ground, making it ridiculously easy for ships to dock.
Exactly, and the upper tip, that's where the magic happens. It could fling the spacecraft out of Mars's orbit entirely to Earth, Jupiter, Saturn, or wherever you need to go.
Wait, so you're telling me that the same tether could act as a gateway not just to outer planets but also to our inner solar system?
Exactly. Venus and Mercury are just a single swing away with this setup. And that's huge, right? Venus is a solar energy jackpot. It's like the hottest planet in the solar system. And Mercury's mineral wealth could be a gold mine. Literally.
And that's just the beginning. Phobos isn't just a convenient spot for one tether, it's also a potential hub for an entire network connecting the terrestrial planets. So we're not just talking about connecting to Mars to Earth anymore.
Yeah.
We're building a zero propellant transport network for the entire inner solar system.
all based on conservation of angular momentum. So simple, so elegant, right?
Yeah.
So imagine a future where traveling between planets feels less like an engineering miracle and more like riding a train. Efficient, predictable, and cheap.
And the best part, we already have the technology to start building these tethers today.
Yeah, there's really no good excuse for not starting. If you want to explore and eventually exploit the resources of the solar system, tethers might be our best bet.
And with Mars's moons as the centerpiece, is not just a dream, it's almost like a blueprint for us.
And the more we think about it, the less vast the solar system seems. With a few well placed tethers, it could all feel so much closer.
Closer and more accessible. Mars isn't just a stepping stone, it's a hub.
And that's how you make a solar system scale civilization a reality, one tether at a time.
You really love your tethers, don't you?
Hey, if they get us to Jupiter and beyond, what's not to love?